Hi everyone, and welcome to this video on the consumption savings model, the two-period consumption savings model, with the presence of taxes, which would mean that there is a government sector in play in this particular model. So what we're going to do in this video is we're going to go through this whole example of the consumption savings model in the presence of taxes. In particular, we're gonna discuss and pin down this concept of the Ricardian equivalence, which sort of governs these consumption savings models when taxes are in play, particularly how consumption and taxes would sort of play a role, and how it relates to this concept of national savings. Consider this example. We have our simple two-period consumption savings model, but we augment it with what we call a government sector. So now we see that this is getting to look like more like a real macroeconomy with the government. Each agent in this economy, this representative agent rather, has a utility function defined as just a log utility function, LNC1 plus LNC2. And we have here, okay, let's underline the pertinent information. The household starts with 0 initial assets, right? In each period, they have starts with initial 0 initial assets, and that the real interest rate is always 10%. Okay, and what we're gonna have is we're gonna assume that the government purchases in the first period are equal to 1. So G1, government expenditure in period 1 is 1. And in the second period, government spending and government purchases is 9.9. Okay. And in the first period, okay, of course, because the government wants to spend, it needs to levy a tax, right, to fund those expenditures, and that must balance, right? So the taxes in the first period will be 8. Okay, so T1 is equal to 8. And finally, we're given with Y1 is equal to 9 and Y2 is 23.1 for the real incomes of the consumer in periods 1 and period 2. Okay, so clearly, first thing we notice is T2 is missing. We don't know what the levied tax on period 2 is. Well, we can easily calculate that one. So that's what letter A is asking. Okay, so what is, okay, the lump sum taxes in period 2? So A, lump sum taxes, right? So to determine this, we just use a formula. Okay, so recall that the government's budget constraint, long-run budget constraint, is G1. That's their expenditure in period 1 divided by G2 plus divided by 1 plus R is equal to T1, their tax revenue in period 1 plus their discounted tax revenue in period 2. This is all in the present value. Okay, so what we have here now is G1. Well, we know G1. G1 is equal to, in this case, 1, right? That's equal to 1. And we know G2. G2 in this case is equal to 9.9. And we know that the real interest rate is always 10%. So this is 1.1. And the T1 is equal to 8. So this is 8 plus T2. We don't know T2, but we know that 1 plus R is 1.1. So clearly, okay, we have here 1 plus 9.9 divided by 1.1, that's just 9. And then we have here 8 plus T2 over 1.1. And from here, right, we obviously know that this is 10 equal to 8 plus T2 over 1.1, which would mean that 2, transpose 8 to the other side, 2 is equal to T2 over 1.1, which would mean that T2 is equal to 2.2. Right? So this is the tax, the lump sum tax imposed in the second period. Right? So pretty straightforward. We just use the government budget constraint. So that finishes letter A. Okay. Now let's go to letter B, which is to compute the optimal level of consumption in periods 1 and 2, as well as the national savings. Well, to do this, okay, we form the Lagrangian. We form the Lagrangian, right? And the Lagrangian is simply, okay, the utility function, right? C2 lambda. That's the utility function ln C1 plus ln C2 plus lambda times y1 minus t1 plus y2 minus t2 over 1 plus r minus C1 minus C2 over 1 plus R, right? So we have that one there. Then from here, we use the first order necessary conditions, okay? So we take the derivative of the Lagrangian with respect to C1. What do we get? Well, derivative of the first term with respect to C1, that's 1 over C1 plus, there's no C1 there, so that's 0. Then in the constraint, it's plus lambda times -1. There's that C1 there, equal to 0, which implies that 1 over C1 is equal to lambda. Okay, so that's pretty straightforward. Next, derive the function with respect to C2. So we have 0 in the first term, then we have 1 over C2 plus lambda times -1 over 1 plus R equal to 0. And that implies that 1 over C2 is equal to lambda over 1 plus R, which would mean that 1 plus R over C2 is equal to lambda, right? So pretty straightforward. Then we take the derivative with respect to lambda. Taking the derivative with respect to lambda, that's just a constraint. Y1 minus T1 plus Y2 minus T2 over 1 plus R minus C1 minus C2 over 1 plus R equal to 0. All right? Nothing new, nothing fancy. So to be able to solve for what C1 and C2 is, that's what we need before we can get national savings. Well, what we're going to do is we need first to combine the first two FOCs. So we have here 1, 2, 3. So notice we can combine 1 and 2, which both can be expressed as equal to lambda, right? So combining 1 and 2, okay, we get here that 1 over C1 is equal to 1 plus R over C2, because this is lambda is equal to that. And rearranging, we get C2 over C1 is equal to 1 plus R. Then what we can do is we can isolate, okay, with respect to one of these. So let's say we isolate C2. So we get C2 is equal to 1 plus R times C1, right? So we have now C2 as a function of C1. Therefore, we can now plug it in our constraint, which is the third FOC, to be able to derive C1, right? So using 3, right? So we get a y1 minus t1 plus y2 minus t2 over 1 plus r equal to c1 plus c2, but c2 is 1 plus r times c1 divided by 1 plus r. So this cancels out, and we're left with y1 minus t1 plus y2 minus t2 over 1 plus r is equal to 2c1. Therefore, this means that C1 is equal to 1 over 2 times Y1 minus T1 plus Y2 minus T2 over 1 plus R, right? So we can easily solve for C1 star now. So that's 1/2 times Y1. Well, Y1 is 9, T1 is 8, Y2 is 23.1, T2 is 2.2. That's what we computed for in part A, divided by 1.1. So let's see, what can we do to simplify this? This is 1 over 2. 9 minus 8 is 1 plus 23.1 minus 2.2 divided by 1.1. Well, that's 19, right? So we're going to be left with 1 over 2 times 20, and that's obviously 10. So we get C1 star is equal to 10, right? So we have C1 star now. How do we get C2 star? Well, that's simple. You know that C2 is equal to 1 plus R times C1 based on this, right? So C2 star is equal to 1 plus R times C1 star. So 1 plus R is 1.1 times 10, meaning C2 star must be equal to 11, right? So that's C2 star. So we're not done with this question yet. We need to compute for national savings. Well, national savings as NAT, okay, period 1 is equal to Y1 minus C1 minus G1, right? Well, we know Y1. Y1 is equal to 9. C1 is equal to 10. And G1 is equal to 1. So 9 minus 10 is -1, minus another 1 is going to be -2. So this is -2. So S not 1 is equal to -2. Okay, that's what we have there. Okay, so simple, straightforward. Okay, that's number 2. Okay, so letter C. Okay, letter C. Consider a tax cut in the first period, okay, of 1 unit. So say there was a tax cut in the first period of 1 unit with government purchases left unchanged. So there's no change in the G's. Okay. What is the change in the national savings in period 1? And it asks us to provide an iteration of the result. Well, that's where we sort of bring up this concept of Ricardian equivalence. Okay, so since government purchases, purchases are unchanged, okay, a change in the lump sum taxes as described in the question, okay, leads to no change. Okay, leads to no change in consumption. And of course, because there's no change in consumption, there will be no change in the national savings. Okay, so there will be no change in the national savings. And this is because of this Ricardian equivalence. Ricardian equivalence. And it just basically implies to us that consumers, okay, increase, okay, their private savings after a tax cut, which is expected, right? Tax cut, because they anticipate, because the government's constraint must anticipate the tax increase, because again, the constraint has to bind the tax increase that must occur, that has to occur, that occurs in period 2. Right? So because they anticipate a tax increase in the second period, they will increase their savings in the first period to compensate for that potential increase in the second period. So to smooth out consumption. So that's this concept of the Ricardian equivalence, right? So that's what happens when a lump sum tax is levied. Now, of course, okay, there are other scenarios that could happen. Okay, so that answers C. We discussed in the past videos this concept called a credit constraint, or this borrowing constraint that we impose on the consumer. So suppose again that we retain T1 is equal to 8, but we now impose a credit constraint wherein that it basically says that consumers cannot be in debt at the end of period 1, which means that they cannot have negative savings or have owed money at the end of period 1. Okay. So the question is, will this credit constraint affect consumers' optimal decisions? The answer is yes. And is this credit constraint welfare enhancing or welfare diminishing or welfare neutral? So let's understand this question. It's actually quite simple. Okay, D. Recall that when we calculated here, we know that C1 star is equal to 10 and Y1 is equal to 9, right? So Y1 is equal to 9. Therefore, if there was no credit constraint, okay, consumer would have borrowed, okay, would have borrowed, okay, and that means that A1 is -9, okay. But, with a collateral constraint, that's CC, with a credit constraint or collateral constraint is CC, okay, it's not possible for this, and A1 must be equal to 0 to satisfy this credit constraint, satisfy CC. Okay. Therefore, okay, because of this, C1, the best thing that it could be is just going to be Y1 minus T1, right? But Y1 is equal to 9, T1 is equal to 8. So C1 will now be equal to 1. That's the best the consumer can do with the credit constraint, because they still have to pay the taxes in the first period for sure, right? They have to pay that. So clearly, clearly, the credit constraint diminishes welfare, because it forces the consumer to choose an allocation different from the unconstrained case. Okay, so remember the unconstrained case, C1 star is 10. In this case, is now just 1, right? So how do you prove that mathematically? Well, you can plug in C1 is equal to 1 in the utility function and compare it with the original case and solve for C2 and that sort of thing. Okay. So last question. So that's D. Okay. So E, okay, now, okay, we still apply the credit constraint that we had. Credit constraint is still in place, but we have a tax cut of 1 unit in the first period. So that would mean that T1 being equal to 8 will now become T1 equal to 7. So the tax is less. Okay. But notice this is different from letter C because there's a credit constraint in place now. And we're now being asked, what is the change in the national savings in period 1 that arises because of the tax cut? And we need to provide some economic intuition as a result for that. Well, that's sort of simple. E. Okay, well, if T1 goes from 8 to T1 star goes to 7, then we know that in the presence of credit constraint, we have that C1 is equal to Y1 minus T1, which is equal to 9 minus 7, which is 2. Notice the credit constraint here is still binding. Therefore, S1 national is equal to Y1 minus C1 minus G1. Okay, that's the formula for that. Will fall, okay, will fall exactly by the amount that consumption rises. Okay. Notice in this case, C1 was equal to 1. That's letter D. But in this case, C1 is now equal to 2. That will affect the national savings by exactly the amount that consumption increased, right? So that a national savings will decrease by 1, okay? Which is 1, right? And you might ask, well, why is this the case? Why? Again, it's this Ricardian equivalence, particularly when it fails to hold. Ricardian equivalence fails if the credit constraint is binding. So what's the reasoning for this reason? Well, consumers not at the unrestricted, okay, choice, okay, the consumers are not at the unrestricted choice. We're not in the case of C, right? So we're not in this case, therefore, I'm sorry, we're not in the case of B. So we're in this suboptimal route to begin with, okay? And because we're not at this unrestricted choice, any relaxation in the period one, in the period 1 budget constraint will induce the consumer to consume more, right? To consume more, which implies that national savings, because it's minus C1, national savings will go down. Okay? And that's the reason why. So That's it for our example on the consumption savings model, the two-period consumption of savings model with a government sector, and this concept of the Ricardian equivalence. Quite an important concept in economics, if I do say so myself. So thank you for your attention, and I'll see you in the next video. Thank you very much.